Hey guys, welcome back. In this particular video, we're going to take a look at routing on the ASA. Specifically, we'll take a look at static routes. My objective is to show you how you configure static routes on the ASA. The concept of static routes you should be aware of already, but we'll review it real quick over here. We'll take a look at not only the normal static route that you configure and the configuration command for it, we'll also be taking a look at the static route, the specific special static route called the default route. Again, the configuration commands, how do you verify it? We'll do a lab that will set up the entire topology using static routes based on the previous lab, where we have already done the IP configuration on the interfaces. So what is static routing all about? Basically, static routing allows the administrator to configure what? The device, in our case the ASA, so that it knows about remote routes. In order to do the static route commands on the ASA firewall, you use a command called route. As I explained in the previous video, when you go onto a router like a Cisco router, it had the capability initially to run routing for IP, IPX, AppleTalk, different type of routed protocols. Now, because you had these different type of protocols, when you wrote a command, you needed to make a distinction between the command as an IP command versus an IPX command versus an AppleTalk command. On the ASA firewall, you don't have any of those routed protocols. In terms of the firewall, it only supports IP. So there's no need to make a distinction between IP and IPX. So the command over here, most of the commands, like we have already seen the show route command, it's missing the IP in the middle. Similarly over here, rather than typing in the IP route command that you do on a router, here we're going to be using the route command to set the static route. So the administrator will create the static route because he knows about the entire topology. You don't want to run a dynamic routing protocol which communicates with the other router about its routes. I want to do it manually. Although it is something that does not generate any overhead on the network, it is not suitable for a large or a dynamic environment where you have a route added into your network on a regular basis, or it's a large network where you need to keep up with the large routing environment that you have. Not only that, if a route goes down in this case, you would need to manually either take the route down, or you might have a route to forward the traffic to the next stop even though the route is down. All right, those are the pros and cons of static routing. Nothing new over here except for that we don't use the IP route command to do it. Here we use the route command to do it. There are subtle differences in the command. Let's take a look at them. So in the normal IP route command on the router, we use the command as IP route followed by the destination network. Let's say we want to get to 10.1.1.0. We would put the mask followed by the next hop. Let's say in our case 10.11.11.1. Now the same command on a ASA firewall is a little different. First of all, it starts with a route command followed by the exit interface, the interface that I'm going to use to go towards this particular network. So in this case, I would specify the name of the interface. Again, as I've been telling you all along, further commands that you configure after you have configured the name of the interface will point to the name of the interface. So I'm basically saying I want to do a route, I want to create a route towards the 10.1.1.0 network, whose mask is 255.0.0.0, which will be reachable via the inside interface. So this is your exit interface over here, and this is your next hop, right? Very similar to the way you do the route command on a Cisco router, with the difference that you do have this additional parameter called the exit interface that you need to specify. Other than that, it's pretty much the same. You're missing the IP command. I told you why you're missing the IP command in the front. So this destination, this mask, the exit interface, and the next hop. That's how you do it. Now, similarly, we have a default route. What does a default route take care of? If you have a large routing table and all the traffic for a particular router exits from a specific interface towards a specific next hop, I can use a special destination address in my route command. On a router, it used to be IP route 0000 and the next hop is let's say 192.1.20.2 in my case, which is router 2. This is how you would do it on a router. Now, if it's a it's an ASA firewall, the same thing. Route 0000, 0000, and the next hop. Oh, one small little thing, exit interface. And so in my case, route outside, because it's an ASA, 0000, couple of zeros, the network, the mask, and the next hop. So basically, it's a static route with a special destination address and a destination mask. Now, one of the things that you can do on a ASA firewall is you can abbreviate the zeros. Let me show you that in the command, the syntax section over here. The default route syntax, exit interface, which generally is going to be towards the outside because that's towards the internet, the network, and the mask, and the next hop. All right, so route outside, 0000, 0000, next hop. Now, you do have the ability to, rather than writing the whole 0000 over here, you can abbreviate it and write a single 0 to represent the network, single 0 to represent the mask. So I could technically write the command as 00.192.1.20.2. Although I write it like that, when you go and check your running config, you will see the running config still display the default route in its full form, which is going to be route outside 0000, 0000, and the next hop. So the whole thing will be there. It would not abbreviate it in the running config. You'll see the full form over there. All right. So that takes care of the syntax of it, some verification commands. You can do the show run route command, shows you all the routes that you typed in your running config. Show route is your routing table, ping to verify the connectivity if it's there or not. So based on that, I'm going to be doing a lab. We have already configured the IP addresses on the interfaces in the last lab, where I configured this as 4.4.10, 3.10, 11, 10, 11, 11.10, and 192.1.20.10, and we verified reachability to the directly connected interfaces. So that part is already done. Let's go ahead and verify that first, and then we'll go ahead and do the lab. So let me bring up my ASA firewall over here. Show interface IP brief. If you guys remember the command to check the interfaces, let's check connectivity. This is my outside router, router 2 again. You should have the PPT, so you should be able to see the what do you call it? The topology. So 20.2 is my next hop. Let's go ahead and check that. Can I ping it? Pingable. 10.11.11.1, which is the inside router, router 1. 192.168.3.3, which is router 3 on the DMZ3, and 4.4 on DMZ4. So all my directly connecteds are reachable. You can do a show route to check the route, just like a routing table. It shows you the connected route. That's the actual network on the inside network, and then the actual address of that, the local DL interface on that particular network. So based on that, we'll be doing the lab to see if I can establish connectivity to some other routes in this topology. This lab builds on the basic initialization lab. That's what I was showing you right now. Configure static routes on the ASA to provide it reachability towards the loopback networks behind the surrounding routers. Configure default gateway or default route on router on the ASA towards R2. Configure static routes on the ASAs towards the 10xx networks behind R1, R3, and R4. Ping these networks to verify the reachability. So basically what I'm going to do, if you take a look at your topology, all the 10 networks is what I'm going to create the routes for behind R4, this guy, these two routes over here, and then towards the outside, I am going to point a default gateway towards him. So I should be able to reach all the networks over here with the default gateway. So let's go ahead and take a look at if that works. So I will go over here. I'll start with the inside networks. What do I have on the inside? I have 10.11 is directly connected. I have 10.1, 10.10, and 10.20. So go into global config, route inside, because I'm going towards R1. That's my objective. My exit interface is going to be this inside interface over here, because I want to reach 10.1, 10.10, and 10.20. The next hop is going to be 10.11.11.1. So let's put that in over here and have my internal connectivity established. 10.1.1.0, the mask, and then the next hop. I'm going to do the same thing for the 10.10 network. Through the same next hop, and the same thing for the 1020 network. So let's see if I can ping it now. First of all, let's check the route. Show route. You can always do show route static to see only the static route. So I have 10.1, 10.10, 10.20, all reachable via 10.11.11.1, the inside interface. Let's ping it. There you go. Reachability is there. We've done that. Now we have 10.3 and 10.4. 10.3 is via DMZ3. 10.4 is via DMZ4. So let's go ahead and do that now. Route DMZ3, 10.3.3.0, the mask, and the next hop is 3.3. Route DMZ4, 10.4, 4.4. Let's ping those. There you go. Show route static. Now the two routes come in from 10.3 and 10.4. The last one was the default route that the lab was asking. Configure default route towards ASA2. ASA2 in our case is 192.1.20.2. So what I'm going to do over here is I'm going to do the abbreviated version of it so you guys can see it. 0 for the first 0. This represents this set of zeros, default gateway. Second 0 for the mask, and the next hop. Show route, and you shall see the default route at the top. Or you can also do show route static. Should show you the default route at the top. And I can now ping 199.111, 200.111, or 10.2.2.2. These are 3 loopbacks behind R2. And that's this particular one. We did the ping. 10.1, 10.10, 10.20, 10.3, 10.4, and the default gateway. And the pings, we tried all of the pings. They worked. All good. Done with the lab. So this is the static routes. Among these static routes, generally on the ASA, you would probably do the default route. The other ones, internally, you probably run a routing protocol, which is a better way of doing it. All right? Simple lab, but gets you started. The next lab we'll take a look at now is your dynamic routing protocol labs. We'll start with RIP, and then we'll move on to EdgeRP, OSPF, and BGP. Hope you guys enjoyed it. See you guys in the next video.